Maxima and minima part 4 prove that the semi-vertical angle of the cone of maximum volume and of given slant height is tan inverse root. We consider a cone, let this angle is alpha, slant height is given, it means it is a constant. In terms of slant height, we can write the radius and height. So let's write it. So OA upon L, that is perpendicular upon hypotenuse. So perpendicular is R upon L equal to sine theta, from where we get R equal to L sine theta. Similarly, base upon hypotenuse equal to cos theta, and base is OB, OB is H upon L equal to cos theta, from where we get H equal to L cos theta. Now we write volume because that is to be maximized. So volume equal to pi r square h divided by 3. That is 1 by 3 pi r square means L square sine square theta times h is L cos theta. So it becomes 1 by 3 pi L cube sine square theta times cos. Now we differentiate the volume. So dV by d theta equal to pi L cube divided by 3 times. We apply product rule. So sine square theta into the differentiation of cos theta gives minus sine theta. Then plus differentiation of sine square theta will give 2 sine theta cos theta times cos theta. From here, we can write pi L2 by 3 minus sine root theta plus 2 sine theta cos square theta. For maxima or minimum, we generally equate first derivative to 0. So we write dv upon d theta equal to 0. So from here we will get minus sine cube theta plus 2 sine theta cos square theta equal to 0, which implies minus sine theta times sine square theta minus 2 cos square theta equal to 0. Sine theta does not equal to 0. If theta equal to 0, here this angle is either alpha or theta. So alpha equal to theta, so we will be confused. So sine theta can't be 0, otherwise cone will not be formed. So this term will be 0. So sine square theta minus 2 cos square theta equal to 0. So this will give sine square theta equal to 2 cos square theta or tan square theta equal to 2, which implies tan theta equal to plus minus root 2. Here, tan theta can't be negative, so we will take only positive value. So tan theta equal to root. Now we have to check tan theta equal to positive root. So from here we can get theta equal to right. So theta equal to tan inverse root 2, which is our answer. But we have to check whether this value is maximum or minimum. So we have to go to second derivative test. So let's differentiate dv upon d theta again. So if we differentiate dv upon d theta, so d2b by d theta 2 equal to pi L cube by 3, and this will become minus 3 sine square theta times cos theta, plus this will become 2. We apply product rule. 2 cos theta times cos square theta plus 2 sine theta into 2 cos theta times sine theta. Now we put here we have got tan theta equal to root. If we draw the triangle, so we can easily get other values. So this is theta. If tan theta is root 2, means root 2 perpendicular upon base. So this will be equal to root 2 square is 2 plus 1. Root 3. So we put these all values here with second derivative to check whether d2b upon d theta 2 is positive or negative. So d2b by d theta 2 will be equal to pi l cube by 3 minus 3 sine square theta. It means perpendicular upon hypotenuse. So this will become 2 by 3 cos theta base upon hypotenuse. So 1 upon root 3 plus twice of cos theta base upon hypotenuse 1 upon root 3 into cos square theta 1 upon 3 plus 2 sin theta 2 into root 2 upon root 3 times 2 cos theta will give 2 into 1 upon root 3 into minus sin theta, that is root 2 upon root 3. So overall this will be negative. It means function is maxima, and in that case theta will be tan inverse root. So I think you must have understood. Now let's go to next question. Question 2 says, prove that the semi-vertical angle of the right circular cone of total surface, including area of the base at maximum value, is sine inverse 1 upon root. So let's draw the cone. Suppose this angle is theta. Now slant height is L, this is H, this is so total surface area S can be written as pi r L plus pi r square, or we can take common pi r then L plus r, and volume is given by V equal to 1 by 3 pi r square H. So here Pythagoras theorem will hold L square equal to R square plus H square. So H square equal to L square minus R square. So if we square this term, V square equal to pi square by 9 R power 4 into H square. So we can put value of H square here. So we can get 1 by 9 pi square R power 4 times L square minus R square. So we can replace value of pi square from here. So we can replace this value. So it will become 1 by 9 pi square times R power 4. In place of L square, we can write S upon pi R minus R whole square minus R square. Let's see how. So from here, S equal to pi R L minus pi R square. So we need a value of L. So what we do, we write S minus pi R square divided by pi R equal to L, or S upon pi R minus pi R square upon pi R equal to L. So from here we get S upon pi R minus 1 r will be left from the pi will cancel out. So we have got this value. Now let's write it further. So we have got v square. Now we can take this v square as another constant v dash so that our calculation will become easier. So we can say that v dash equal to, here these terms also we take as constant. So what we do, we can take this r power 4 inside, and by pi square we can remove being constant, and that will be grouped with. So v dash equal to 1 by 9 times this r power 4 can be taken inside, and when we expand it, so suppose we expand it, so it will become s square upon pi square r square plus r square minus twice of s upon pi r times r minus r square, and this pi square r power 4 is kept intact. We will not remove till we simplify it. So let's see what we are getting. R square will cancel out. Then what is left? So let's take this pi square r power 4 inside. So now what do we get? V dash equals 1 upon 9. If we multiply pi square r power 4, so pi square will cancel out, r power 4 and this is r square. So r square will be left. So we can say it will become s square r square. What about this? When pi square r power 4 is taken here, so here 1 r is automatically cancelled. So we get 1 pi will get cancelled. So we will get 2 pi s r power 4. So we have got v dash. Now let's differentiate it with respect to r. Here volume is expressed in terms of r and s being constant. So dv dash divided by dr will be 1 by 9 times r square derivative will be 2r. So 2r times s square minus this will become 4r cube. So 4 to the 8 pi s r cube. We also evaluate second derivative here, so it will be easier. D2 v dash divided by dr2. When we evaluate it, so it will become 1 by 9. R will give 1, so 2s square minus r cube. Derivative will be 3r square. So 8 3 are 24 by 24 pi s r square. This is second derivative. Now we equate first derivative to 0. So let's write dv dash divided by dr as 0. So from here we get 2r s square minus 8 pi s r cube equal to 0. So that will give, here we can take 2r, then s square minus 4 pi s r square. So s can also be taken common. So we will take it common in next step. So this equal to 0. So r can't be 0. So We can say this term can be 0. So s square minus 4 pi s r square will be 0. So here s we can take out, then s minus 4 pi r square equal to 0. So from here, this s can't be 0. So we get s equal to 4 pi r square. Now, let's check the value of second derivative when s equal to 4 pi r square. So here we have to write s square, so that will be 16 pi square r power 4. And here we have to write 4 pi r square. So let's write and check the sign of second derivative. So it becomes d2v dash divided by dr2 at s equal to 4 pi r square. So it will give 1 upon 9 times twice of s square. So in place, here we have got s equal to 4 pi r square. It will be easier to write the value of 4 pi r square here and keeping s square intact. So 2s square minus, if we take out here 4 pi r square, then what will be left? So it will be 6s. So 4 pi r square is s itself. So we get 1 upon 9 2s square minus 6s square, which is minus 4 upon 9 s square, which is less than 0. It means second derivative is negative. So if second derivative is negative, then function is maximum. Now our work is to put the value of s here to get L and R. So let's see how we write in place of s 4 by r square. So let's clear it. So we have got s equal to pi r and then L plus r, and we have got s equal to 4 pi r square. We can put this value here. So 4 pi r square equal to pi r times L plus r. So pi will cancel out, one r will cancel out. So we will be left with 4r equal to L plus r. So this will give 3r equal to L. So if we consider the previous triangle here, sorry, not this, we can redraw it. This is R, this is H, this is L. And we have got here L equal to 3R. So if we find R upon L, R upon L, here R is perpendicular and L is hypotenuse, so that will be sine theta. But R upon L equal to 1 by 3. So sine theta will be 1 by 3, or theta equal to sine inverse 1 by 3. So this was our purpose. As question was, prove that the semi-vertical angles of the right circular cone of total surface area and maximum volume is sine inverse 1 upon 3. So we have got the answer. Thank you for watching.